Good morning, Math 2 students. It is early Monday morning, and I'm so excited to teach you something new this week. I couldn't sleep last night. I hope everybody's doing okay. This is the last week. I think it's week 4 is what I'm going to title this video anyway. And after this, we have a week of vacation. I don't know what the difference is between a week of vacation and a week of school these days, but hey, that's what's coming up. I'm going to jump over. I mean, if I'm doing this right, you will, in a second, see a piece of paper. I hope you're seeing this thing right here. This is a piece of paper I've got on my desk right next to me. I'm going to slide over. Um, let's talk about what we're doing here. There are many different ways to solve quadratic equations, and you can see some of my work here on this paper as I'm talking. We know how to solve quadratic equations by factoring. I'm going to do 2 problems, an easy one and a hard one. And then I'm going to teach you another way to solve quadratic equations. It's called using something called the quadratic formula. But let's look at this. So what we know is that when we're solving equations, when we're solving quadratic equations, no matter how we're solving them, we always want to collect every term over on one side so that the equation is equal to 0. That's a really, really important step that I see so many students forgetting to do. You have to rearrange the term so it's equal to 0. And by the way, you want x squared to be, the x squared term to be positive. It's negative. I would multiply everything by negative, change the sign of everything. But in this case, it's not. It's a nice positive x squared. This one I can factor in my head pretty easily. I know that x squared minus x minus 6, I want to factor this. This turns into x minus 3 and x plus 2. Don't forget the equal 0. That's part of the equation. If I don't write it, it's no longer an equation. So I could double check. X times x is x squared. My inners are -3. My outers are +2. That adds to -1x, -3. Okay, it looks like I got it. That's great. Now what I know is that x minus, oh, my pencil's about to break. Either x minus 3 equals 0 or x plus 2 equals 0, right? If I'm multiplying 2 things, my answer is a 0. One of those 2 things must be zeros. So anyways, when I solve this now, I'm going to get either x equals 3 or x equals -2. I want to write that bigger. X equals 3, comma, -2. There's my answer. That one was easy. The next one, though, check that out. That's going to be hard to factor. I'm going to use my calculator. I'm going to play the X game. I'm going to use all the tools at my command to figure out how to solve this. I've got a calculator a lot like the ones I have in class. If you have a calculator, you're going to want it to do this week's homework. Let's see. 24 times -75. Oh, first thing I should do is I check, is this, let me draw a line here so I can make this stand out a little bit better. Is there a GCF? Is there anything I can factor out of this? Well, I can factor 3s and 5s out of this, but I can factor a 5 out of this, but not a 3. I can factor a 3 out of this, but not a 5. So nope, there's no GCF. I can't factor anything else out. So what are we going to do? We're going to do 24 times -75. 24 times -75. -1800. I'm looking for 2 numbers to make -1800 that add to 70. Oh my gosh, that's huge, right? Look at that, 24 times -75. Let me double check. Yeah, what are the factors of this? Well, there's a lot of them. I'll tell you that right now. There are many, 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 and I don't really know what the answer is, and I could list them all out and check them. You know how to do this. I'm not going to take the time to do it right now, but I can. Maybe I should. I'm going to do it, and then maybe I'll fast forward over this part. Let's see. It could be 1 times 1800, 1 times 1800, or 2 times 900, or 3 times 600, or 14, or 4. Negative, if I simplify this, if I divide them both by 4, that's -5, 6. Okay, if I simplify this, 90 and 24, that's not very easy to simplify, but I could take a 2 out. No, I could take out more than that. 8, 6. 90 divided by 6 is 15. So that's 15 over 4. Okay, so this is 6x minus 5 and 4x plus 15 equals 0. And so this is my 6x minus 5, 4x plus 15. Let's double check. 6x times 4x is 24x. Good. 6 times 15 is 90. Minus 20 is my positive 70, and negative 5 times 15 indeed is that. So these are my answers. Either x equals negative 5, 6, or x equals, I'm sorry, that's positive 5, 6, or x equals negative 15 fourths. Whew, that was not fun or easy. It took forever, even with a calculator. So there are better ways to do this. This formula right here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. It's such a famous formula. Students all around the world learn this. Many of them have to memorize it. I'm not going to expect you to memorize it. Next year in Math 3, you'll have to memorize it. But you will want to write that down. If you do a search on the internet for quadratic formula, there will be probably thousands of websites, probably tens of thousands of websites, if not even more, that reference this. Negative b plus or minus b squared minus 4ac all over 2a. So the question is, what are a, b, and c? I know what x is. That's the variable we're trying to solve for. But what are a, b, and c? A, b, and c are these numbers here in front of the problem. A is 24, b is 70, c is negative 75. In this case, a, there's nothing there in front of the x squared, so there's a 1. Right? You can almost imagine a 1 there and a 1 there. A is 1, B is negative 1, C is negative 6. And all you do is you find out what those are and you put them into the formula. So this one here that was so hard to do by factoring, let's see how we could do it by using quadratic formula. What do I know? I know that A is 24, B is 70, C is negative 75. I wish I'd given myself more room, but I didn't. X equals negative B. B is 70, so that's a negative 70, plus or minus. Now, the plus minus thing, you might not have seen a whole lot of before. All that means is that it's actually two answers in one. For one answer, you're going to subtract, one answer, you're going to add, but it's the same thing. I have a huge square root. B squared, so that's 70 squared minus 4ac all over, the whole thing is over 2 times 24. It's a lot of numbers there. Well, let's keep going here. Negative 70 plus or minus. I'm not going to do that in my head. That's why we have a calculator. Oops, make it clear a couple of times. I don't know how well you can read the calculator on this video, but it's 70 squared minus 4 times 24 times negative 75. Oh my gosh, that's a huge number. 1,000, no, 12,100. 12,100 all over 48. Okay, so how do I find this? Well, it's going to be negative 70 minus, remember I said plus minus is you subtract it and then you add it to get the same answers. I'm going to do negative 70 minus the square root of 12100, and I'll divide that by 48, and I'm going to get negative 3.75, negative 3.75. And then I'm going to do the same thing, but I'm going to add it. Negative 70 plus the square root of 12100 divided by 48. And this time I'm going to get 0.83 repeating. Okay, so the question then, how are these answers and these answers the same? Well, this point 0.83 repeating, that matches the 5, 6, right? If I did 5 divided by 6, I get the same answer. So that one matches this. And 15 fourths, well, you can do that in your head, but I guess it's 15 divided by 4 is 3.75 in the negative. So that matches. This matches what we got up here by factoring. That's awesome. That was so much easier. Was it really that much easier? I think so. I think so. And it gave us decimal answers instead of fractions. I don't know which you prefer. Notice I wrote the 0.83 as a repeating with a bar on top. Anyway, so that's one type of problem. There are actually four things that can happen. One, two, three, four. Four things that can happen. The first one is you're going to get a nice decimal answer like that. This one's going to be even easier. I labeled it number 2 here. So let's see. I'm going to go through the same process. A is 9, B is negative 12, C is 4. And then I'm going to plug it into quadratic formula. X equals negative B. Oh, negative 12. That's positive 12. Plus or minus the square root of B squared. You know, I'm going to write it instead of writing it. I'm going to write it like that. B squared minus 4AC all over 2. A is 9. All right, I don't leave myself very much room here. Okay, negative 12 squared, I know that's 144. Minus 4 times 9 times 4. I get a 0. This is 12 plus or minus square root of 0 over 18. Okay, well, what's square root of 0? You can check, right? You can check your calculator. Square root of 0 is 0. Right? What times itself equals 0? 0 times itself equals 0. So that's a 0. So this is really 12. And if I add 0, subtract 0, those are my two answers. It doesn't matter. I'm only going to have one answer this time. It's 12/18, which we know simplifies by divide by 6, divide by 6. I get 2/3. Only one answer on this one. Only one answer. So that's the key thing there. So on this one, we had two answers. Most of the time, we'll get two answers. I had two answers here, one answer here. Okay, third problem. Here comes the third problem. This one's going to be a little bit different. I can't factor that. I could try. I could play the X game. 3 times negative 6 is negative 18. Numbers that multiply to negative 18, they add to 5. There are none. Can't factor it. This is the first one we couldn't do by factoring. And sometimes you can't. Factoring only works on a certain number of problems. Quadratic formula always works. 100% of the time it's going to work. Let's look at this. This is the third type of problem. It's one you can't solve by factoring. So I know that A is 3, B is 5, C is negative 6. Quadratic formula, X equals negative B plus or minus square root of B squared minus 4AC all over 2A. Okay, and I said that with the variables, but really I wrote in the numbers as I did it. X equals negative 5 plus or minus. Okay, this is 5 squared is 25 minus 4 times 3 times negative 6. I get a 97 over 6. This is down at the very bottom of my paper. Can you see that? Okay, let me adjust my elbow here a little bit so you can see that better. Negative 5 plus or minus square root of negative 97 all over 6. There's no easy answer to that. You can't do anything with that. I can't simplify that anymore. I can plug it into my calculator. And oftentimes, we just leave it like that. Negative 5 plus or minus square root of 97 all over 6, and you don't do anything with it. I could if I wanted to with my calculator, and I'm going to in this case. I'm going to find the approximate decimal for that. So I'm going to take negative, I'm going to put this in parentheses. Negative 5 minus square root of 97. Close my parentheses. Ooh, don't close them in there. Close it out of there. Okay, negative 5 minus square root of negative 7 all over divided by 6. And my calculator tells me exactly what I have already. I hit this little button. Now it tells me it's about negative 2.474 8, and you can see dot, dot, dot. It goes on forever. It's a non-repeating decimal because square root of 97 is an irrational number. Now I'm going to do the same thing. I can actually go up. I can hit enter, and I'm going to change this. Oh, switch the order. -5 plus. I'm going to get rid of that little negative sign in front. 0.0, 0.80814 dot, dot, dot. It goes on forever. Okay, so this is an interesting one because it's an irrational number. It doesn't give me a nice clean fraction. It's sort of a messy answer. The fourth one's even worse. What do you see what happens here? A equals 5, B equals 7, C equals 3. I plug it into quadratic formula. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. Oh, I did 7 squared. I didn't write it 7 squared. I wrote it as 49. -7 plus or minus. Okay, let's figure this out. I know I did the easy parts there. Let's figure out what this is. This is 49 minus 4 times 5 times 3, -11. Whoa, we have an error. We have a problem. What's the square root of -11? It's not an answer we know how to work with. You will next year in Math 3. We're going to learn that's an imaginary answer, but it's not a real answer. So what we would typically write is no solution. And really what it means is there's no real solution. There's not a real number that has anything to do with that. You can't come up with an answer because of that negative, right? Any number times itself is positive. We don't know how to take a number and square root of -11. As a matter of fact, what happens if I put that in my calculator? If I go square root of -11, domain error. Domain error. Domain is all the possible x values. It's telling me that -11 is not a possible input into that function, into that square root function. Okay, this is an overview. This is a quick overview of quadratic equation, quadratic formula to solve quadratic equations. There were 4 different examples. This was the easiest one because it was a nice simple fraction with only one answer. Here's some other fractions, a little more complicated. I wrote them as decimals because that's how the calculator gave it to me. 2 different answers, but still real numbers, rational numbers that could be written as a fraction. This one down here also has 2 answers. They're real numbers, but they're irrational. Irrational meaning they've got square roots that can't be further simplified. And number 4 gives me non-real answers, and so we would write no solution because of that square root of -11. So let me stop sharing the video here. This is really exciting stuff. This is a very, very powerful tool. And this video is a little longer than I wanted it to be. I apologize for that. But I hope you got a sense of how this works. When you do this Delta Math assignment, there's going to be several different levels of this. I want you to not use PhotoMath. I want you to do this. You're going to want paper and pencil. You're going to want a calculator to do this, right? And if you don't have a nice calculator, use your phone. I like a real calculator better. I think well, partly because you can use this on an SAT. You can't use your phone on an SAT. Learn how to use that calculator. I hope this video is helpful. Don't hesitate to schedule time with me. This is our last week together before a week of vacation. See you, everybody.